Hello, friends. This is Reza Mohajanoi, and I'm gonna present my work as my project, semester project of this course, Advanced Operating Systems. And since I was gonna, I have always been interested in operating systems and how they work. And as I am myself a Linux freak, I would like to um, implement my own Linux, kind of develop one kernel, understand what kernel is. Um, I always liked to develop operating systems. My personal desktop is always, at least for from 10 years ago so far, and will be an Ubuntu. And I'm really interested in Linux and some open free, some other open free operating systems. And this is my background. And because of this, I have always been interested in learning low-level languages such as C++. After that, I went and searched what an alternative for C++ would be, and I came up with an option of Rust. I learned Rust. Rust is a low-level language which gives you some good access to low-level hardware system, but meanwhile has some garbage collection possibilities and so on. This is some a bit higher level than C++ and C and maybe Java, but though it's gonna get you some access to low-level hardware, it's some really comfortable language to learn, not to learn because it's so abstract in the beginning, but after you get familiar with it, it's gonna be comfortable. Anyways, now I try to take this risk or challenge to kind of start writing a real program in Rust. And this is gonna be my first operating system in Rust. And to be honest, my first operating system ever. But I had some challenges. In the beginning, I started by big dreams, big goals, but now I understand that this is a hard task to do. So in the beginning, I wanted to mount a hardware driver, such as maybe a Wi-Fi card driver to that operating system, that possible potential operating system. But in after some phase, I figured out how hard it can be, and then uh, I I was kind of that became okay for me to deal with a VGA, even a VGA screen in which you can write your operating system can command the hardware to show some text on it. That was hard enough, let alone hardware drivers and some kernel you design. So this is my code as you see here. This is my project code. It's gonna show a hello world on the screen. It's gonna command the VGA driver maybe or VGA screen to show you some hello world. So if you can, if I want, I can in future develop it to do maybe other things, but it's just a beginning. It's just a start. So um, let's go over the code first, and then I will uh, show you a demo. The first thing I want to mention is we don't need to, we can't, in fact, im import some high-level packages because we want to design some bare metal kernel. So we don't have any access to high-level packages to do complicated things. So we don't have any STD, no standard in Rust. This is how it's been defined. And again, we don't have any main function. In most standard kernels, bare metal kernels, we have a start function as an entry point. As you know, as you can guess, uh, a bootloader loads a kernel for us. uh, the kernel is not gonna be loaded by itself. Something other than that, meaning the bootloader has to load that. And this has start from somewhere. This is called entry point. So the entry point here in the end is being defined as underscore start. And let me show you here that the hello world is going to be written here. And we have to define these functions, these higher level functions, print, ln, print, things like these. And I will show you how I did that. There's a possibility in Rust, something similar to error handling things in C++ or Java or Python, maybe. Yeah, Python also has something like that. But here it's called panic info. It's a bit different than um, error handling in other languages. This its role here is to just handle if some uh, undefined, unprecedented error happened, something strange happened that the kernel doesn't know what to do with it. And after it happens, it will go to a loop. It will first print something, some error, or let the user know some error happened, and then go to a loop to just show the user what happened recently in the end, and not end the program suddenly. So this is what I used as a function, as a prepared function. This is not an import. This is standard Rust. Then we have some VGA buffer. The VGA buffer by standard, again, starts at this address. I mean, this 0xb8000 is some standard in kernel development. Most of the languages, most of the kernels do that in the beginning of the code. So I try to just copy that, and we will have some 80 some 25 by 80 VGA screen. This is the size of our screen. Suppose it's a VGA screen, hardware one, and we want to use some emulator to show that to you. And we will have to define some colors, as we don't want to have only two colors, white and black. We want to have maybe blue, green, red, yellow, so on. As in this program, we will use yellow for foreground, the text, and black for background. Then we will have some color code as integer. Integer is shown like this in Rust. So a color code is a byte, 8 bits, and the left 4 bits are for our background, which in my case is gonna be black, and the 4 right bits are gonna be the foreground, the text color. In my case, is gonna be yellow. This is the structure I chose, and I think this is the standard way of designing things like this. So to show you some text on the screen, I have to first have a color code, and maybe we'll show here for you. We will have a screen character in which we will have the character itself as ASCII character, which is itself an integer again, and also the color code. And these are two different bytes. The color code is a byte itself, and also we have the ASCII character, which is gonna be which are gonna be combined and be shown on the screen. Then we will have the buffer. A buffer, as you know, is, as you may already guessed, is a grid, some tables of it's like a matrix of buffer width by buffer height of screenCAR objects. screenCAR was a 2-byte data structure, and we have 25 by 80 maybe pixels or elements of that matrix. Then we will have a function called writer. This is a low-level implementation of that, and I have been inspired by some GitHub codes to implement that. I'm not gonna go into the low-level side of this to show you how just low-level write function will work, but I can just let you know that if you have questions, I will answer those in discussion board. Just ask me and I will kind of explain it to you. But I will just say that this whole class in Rust, classes are defined like this. This is a declaration of the class. This is the implementation of the class. And all of these are needed for my implementation of writing on the screen, or writing using this data structure. And I use this class to just implement this uh, this lazy static is to just use the write once, initialized once, and assigned once as we needed, maybe, for example, we need it twice or 3 times. For the second time and the third time, we won't have to reinitialize that, redefine that, and we don't have to waste the memory to initialize write object 3 times or twice. So this static lazy assignment will help us to save some memory and use the already assigned one again and again. Then we will use this write function for our print. This printing possibility will help us define these two higher level print functions. I should have defined something with this name. Yeah, this is the one that uses the write class that I just showed you. And this is the way Rust formats the arguments, format the text, and finally, this will either give us an error or an OK message, and this is gonna unwrap that message. By the way, our writer is gonna lock the IO, so this lock function is gonna lock the IO so that nobody else could use it while this function is gonna use it. Then, since I just said that this underscore print function uses writer, I will say that I should say that our print ln and print macros will use this underscore print, as you see here and here. Again, this println function will use print maybe twice. In case we don't have any argument, it just will show some next line. If it has arguments, it's gonna format it using formatting options we have here. And then we will use this start function. This start function is gonna use C wrappings because C is the standard function for um, defining and designing kernels and operating systems. This is most of this is the thing most of the bootloaders will deal with. So if we define this start function, this entry point as like this is gonna help compatibility. This is just for that. And then we will write hello world and ran successfully, things like that. And after that, again, we had some panic function, which is gonna control and handle the errors. I had some loop here. I just removed it. Okay. And we have some, like some other languages, C++ and maybe Java, we can return zero or return nothing. So this is what I already have. Let me delete this binary file to just show you how I make it in Rust. Cargo is a builder, system builder, which um, is a real compiler of the Rust language. And now I use this JSON function, this JSON file to build this program with the files we have, such as main file you see here. This is gonna say what prerequisites we need for this project, what requirements we need. And then after let me just show you how it is gonna be built. Oh, sorry. Yeah, you see there's nothing here. And after running this, we will have this boot image. Oh, this wasn't here. It's, let me delete it and show you again. This is gonna show up. It's gonna be, sorry again. Why did I show you in files? I will show you here. Um, back again. Let's just show you. I will build it. Here it is. Here's our boot image. This is what this is the OS we have here attached to a bootloader. So this is something like the setup we have for Ubuntu or Windows, and we can install it on computers. This has been loaded by a bootloader here, and to run it, we can use some tools such as Qemu. Qemu is an emulator of the hardware. Since I don't have any hardware to install my OS on that, I use Qemu system x86 underscore 64. This is a standard, well-known uh, application for you to emulate some hardware to install um, your OS on. And here is what we have. I think that something here has a problem. Let me just find it. Oops. Why twice? And open targets. Let's see what where target is. Target is here. So let me just again run it here in the right path. Oh, finally. Hello world successfully. And to not go into the loop, because I have experienced this before and my laptop crashed, I just have to close it sooner. As you see, my OS, my first OS has worked. I have worked some while on that, but there is still much to learn about this and develop this. And thank you for your attention. I hope it has already been a quarter of an hour. Yeah, it is maybe. So thank you. Any questions are welcome from you. I will answer them inside the discussions board. Thank you everyone and good luck.